All right, spaced out viewers, thanks for tuning in. Congratulations on realizing our channel exists. Let's get to it. There's an SDO calibration maneuver going on there. The SDO sometimes makes sure that it's perfectly centered on the solar disk. That's what you're seeing with that little bit of data loss happening there. This is 171 angstroms from the SDO, my favorite wavelength. That's ionized iron, if you're wondering what it is you're looking at. You're looking at the ultraviolet emissions of an ionized state of iron. Iron 9, I believe is what it is. We do have a coronal mass ejection warning continuing, and a solar flare warning as well. The likelihood of Sunspot 2882 producing additional large flares is certainly in effect. To watch flares happen, 94 angstroms is a great wavelength. It takes 10 images per minute instead of only 2. That and 131 have these properties. Let's take a look at Lagrange point 2 and Lagrange point 1 and Lagrange point 5. As we have got, again, a coronal mass ejection warning in effect. So the left pane you're going to see here is stereo A. You can see massive plumes of plasma here extending outside of the coronagraph. Something like, 6, 8 solar radii there. And there was a coronal mass ejection yesterday. It was not Earth-directed. It was off to the west. The pane on the right that you're looking at here is the Soho-Lascaux C3, which is located here at Lagrange point 1. Again, stereo A located at Lagrange point 5. Puts the Earth off to your right from there. And again, coronal mass ejection warning in effect. Some of this plasma will be blasting off, and it will be somewhat in the Earth-facing vicinity. For you new viewers out there, we only forecast coronal mass ejections in approximately this area, as that is the earthly zone. We don't forecast them over here. We only forecast them over here. And we've been almost 100% successful with 0 false alarms over the past about 8 months. If you're wondering what our record's like, I think we missed one, and it was only because we downgraded our coronal mass ejection watch. Anyway, here's some more imagery. Coronal mass ejections are good to view in 304 angstroms. This is ionized helium from the Solar Dynamics Observatory. One of the crowd favorites. We've also got coronal holes that we'll cover a little later in the video. Here's the colorized magnetogram. And I want to zoom in on 2882 here. That's this sunspot right here. It's got additional umbrae growing ahead of it there. So that's another sunspot group just spontaneously forming right there. And this sunspot is big enough that it could certainly interact with that. Don't be surprised to see an M-class or even an X-class flare. As that sunspot moves closer and closer to the limb, it is more and more likely to produce a major flare, detectable here at Earth, causing things like HF radio blackouts, and perhaps additional coronal mass ejections will be associated with that. Hence the coronal mass ejection warning and solar flare warning. The 10.7 centimeter radial flux, which comes out right about this area here, the lower corona and upper chromosphere, all the way down to 84. So otherwise, besides that sunspot, mainly in the area around it, low solar activity. There's the 1-year graph, the black line's the radial flux. The red line is the sunspot number. And here's the Space Weather Enthusiast dashboard. We see no solar storms or geomagnetic unrest forecasted for the next 3 days. This will change soon here as there are some coronal hole wind streams on the way to Earth. We're seeing some low magnetometer readings. We'll get to that shortly as well. First, global seismicity. Are you interested in what earthquakes have been shaking, quaking, and rocking and rolling? Well, there's the past 90 days in a convenient bar graph. We love the volcanodiscovery.com tools. Volcano Discovery, if you're watching the videos, drop us a line. We want to interview somebody over at your operation. All right, so here is the Usgs map. No 6 magnitude quakes over the past 24 hours. There was a deep 5 magnitude quake in Indonesia, though. That was 142 kilometers depth. Some other deep quakes there as well, such as this 4.3 at Russia, sort of northeast of Japan there. Chile saw a deep quake at 116 kilometers at a 4.1 magnitude. Some quakes in the Caribbean there. Give us a shout out if you're viewing from the Caribbean. South America saw some deep quakes as well, such as this 4.4 at 150 kilometers. Several quakes there on near the west coast of South America. Another deep quake at Vanuatu. Make it 2, a 4.4 and a 4.5. Those only 20 minutes apart there. Right around 200 kilometers depth on both of those mid-4 magnitude quakes. Some quakes in the Aleutians in southern Alaska. I think the largest of the past 24 was a deep quake at Vanuatu. It was a 5.6. Early this morning at 5:51 Universal Time, that 5.6 magnitude quake at 120 kilometers depth. Also, Philippines saw a 4.5 at depth, so quite a bit of deep quakes here. Quite a bit of deep quakes over the past 24. Let's look at volcanoes. Turns out La Palma is expected to be erupting for an extended period. If you're booking a volcanic vacation, maybe head to the Canary Islands. So the volcano known as Volcano in the Aeolian Islands of Italy, some elevated sulfur dioxide emissions there, and the alert level raised to yellow as a result of that outgassing activity. So La Palma continues to explode, producing a 10,000-foot ash plume. You can read all about it. It's all over the internet. There's a phys.org article about it, I believe, today. And some evacuation orders happening there as it gets closer and closer to La Laguna. I think that's the town. Anyway, my Spanish is less than optimal. Nishinoshima also erupting, I think. Let's see. The activity of the volcano continues with little or no activity as emissions of water vapor and gases venting from the crater, so-called degassing. Subanosejima exploding 8,000-foot ash plume over the Ryukyu Islands. Bagana now exploding over Papua New Guinea. We see it producing a 7,000-foot plume of volcanic ash. Samisa Pochnoi exploding, 10,000-foot ash plume there. The Aleutian Islands volcano, Fuego, producing a 15,000-foot ash plume as it explodes in Guatemala. Sangay and Revenador, both exploding in Ecuador there. 19,000 and 16,000-foot ash plumes, respectively, at Sangay and Revenador. Sabancaya continues to explode, producing a 22,000-foot plume of volcanic ash. And please don't pole vault Nevados de Chilean, even though satellite views are unable to detect whether or not it's erupting. It could be unhealthful. What's not unhealthful is visiting our links and supporting the channel via the links below this video. Please click them. Pick up some merch, perhaps. Maybe become a member of the SMASH team. More on that in today's meteorology segment. Those typically premiere before the daily space weather video. Again, please don't pole vault the caldera. Today's featured product is the Mensa hat, and I'm currently wearing one. So there it is. Yeah, Mensa. Make Earth not suck again. Have you been noticing Earth sucking for the past 2 years? Well, it's up to people like you, people who are not complete COVIDiots, to make Earth not suck again. So Mensa, tell your friends and foes about it. Lots of products there available besides the baseball cap. If you're in the market for something like a shirt or a skirt or maybe even a set of coasters, I think we've got all of that stuff. There's even a dress with the Mensa graphics on it. Mensa, make Earth not suck again. There's even a comforter. There's a duvet cover, I think. There's all kinds of stuff. You can get a shower curtain, a throw blanket. You can even buy a COVIDiotic mask if you like. Mensa, make Earth not suck again. Universum liberate, folks. Universum liberate. Also, make America not suck again, which, by the way, is not some kind of a Trump slogan. It's completely apolitical, as am I. I've never been associated with a political party, and I probably never will. Universum liberate. Mensa, make America not suck again. Mensa, make Earth not suck again. Magagaga, make the galaxy not suck again. I don't know. Anyway, here's smAshomash.com. Welcome to the Neo-Renaissance, folks. Again, visit the links. You can find that merch shop right there at the homepage, smAsho merch. Also links to our forum and to the Smash team. Yeah, smAshomash.com/Smash team. More on that at a later time. Let's look at some magnetic data, like the GOES magnetometers. So we're seeing a pretty tight range here. We're seeing pretty low highs and pretty high lows over the past 24 hours. An indication that there's a coronal hole wind stream in between us and the sun would be my first explanation of that, as plasma has the ability to affect the transmission of magnetic fields. Anyway, a little arc jet moment there, by the way, if you're wondering what that is when the GOES 16 turns on its thrusters, creating plasma and possibly affecting its readings. That's what that means when you see the arc jet start and ends. The likelihood that there is some artificial plasma there affecting the GOES magnetometer readings. So here's the Gong 2 data. This is from 51 ground-based magnetometers right here on Earth, as well as magnetometers out here at Lagrange 5 stereo A and Lagrange 4 stereo B, showing us the polarity of the heliospheric current sheet. And Earth is in a South Pole current sheet, it looks like. That North Pole current sheet there. Oh, it could be a moment of indecision happening there. So, yeah, that's Earth is homeless, magnetically speaking, at the moment. There you go. No orange line, as we see with stereo A and stereo B. Earth indecisive about what current sheet it might be in. Maybe a decision being made there as we see the GOES 16 and 17 diverge in their readings. Here's a line of sight view. And I have no prediction as to which polarity current sheet the Earth will be in, but I'll show you the latest image. There it is. I would say a South Pole current sheet is highly likely to be here by tomorrow. Actually, it could be here already, but the data that we're looking at here is nearly 2 hours old. So here's the line of sight coronal hole plot. The potential field surface source lines shown here in blue are the sun's B field. And we see some major coronal holes here stretching across the equator. Trans-equatorial coronal holes are the most geo-affective ones, and we can expect some coronal hole wind streams coming soon. So make sure you follow our daily space weather videos daily. We've been doing it for pushing 4 years at the moment. Here's the coronal hole imagery here, 193 angstroms from the Solar Dynamics Observatory, and you can see how well defined those coronal holes are, especially on the eastern portion of the Earth-facing solar disk. And just to go back to this, those coronal holes are, this one is North Pole oriented and this one is South Pole oriented. This one here also South Pole oriented. So the solar polar field reversal process taking its good old time, but starting to progress now. And of course, as we forecasted, an uptick in coronal holes. Next, the flare monitor and detected sunspot groups graphics. Again, sunspot 2882 is beta gamma class. This new sunspot here probably is going to be named, that is 2883. That is close enough to 2882 to interact with it. Some may even consider it the same sunspot group. I don't really care. How it's named, as the naming of sunspots is in many ways arbitrary. Again, coronal mass ejection and solar flare warning remain in effect. Here's the GOES X-ray flux over the past 3 days. We did see some C-class intensifications since yesterday's daily space weather video. No spikes in the proton flux, no relativistic particles striking lately in the geospace. Let's look at the real-time solar wind. There's the real-time solar wind, pretty unremarkable here over the past 24 hours. There was a minor shift in the phi angle, otherwise pretty uneventful. The current solar wind density looks like it's around 8 protons per cubic centimeter. Solar wind speed 383 kilometers per second. KP index currently at 1. It's a measurement of global geomagnetism if you're a new viewer. Each one of those bars represents 3 hours. Again, geomagnetic storm happening here a couple of days ago. Continuing on, here's the geospace of the past 4 hours. This is a model by the Space Weather Modeling Framework, it's called. If you want to read about where the data is derived, click on details on the Geospace Magnetosphere Movies page. You'll find a link to the Space Weather Modeling Framework. This is modeled in nanopascals, which is magnetohydrodynamic pressure. And again, it's 4 hours of data. It's courtesy of University of Michigan. We show it daily on the daily space weather. Here are ground magnetic perturbations. Geospace delta B changes to the Earth's B field. Since there's a geomagnetic excursion going on that people are unnecessarily frightened about, we cover it daily, and we hope you don't believe nonsense. Although, if you're viewing the video on YouTube, you might be exposed to lots of nonsense. Like the last frame we showed, this is also 4 hours of data. Changes to Earth's B field, geospace delta B. Continuing on, here's some astrography for you. If you're wondering where things are located in the solar system, Mars feeling a little lonely over there, perhaps. By the way, there is a dead zone going on at the moment. Earth unable to communicate with Mars rovers because the sun is in between the Earth and Mars. It's going to end in a few days. Let's advance this 1 week. And there's where things will be in a week. Looks like a full moon coming on the 20th. Next, a diagram of stars, which are above my head. I'm pretty spaced out, so I use in-the-sky.org. It's the all-sky chart, if you're wondering. The yellow line is the ecliptic. The blue line is the galactic plane. Let's do a brief cosmology segment. This one's integrated into the Daily Space Weather video. If you haven't checked our playlists, youtube.com/smashamash/playlists. That'll be in the description as well. There are, I think, 230 videos in our cosmology segments at the moment of recording this one. Let's talk about a completely unrandom thing. One of the brightest gamma ray sources in the sky, the Vela pulsar. Yes, it's also a bright X-ray source and quite a violent portion of the Milky Way galaxy located near the galactic plane. These are the hard X-rays from the Vela pulsar. It's very famous. If you want to go read about it, go ahead. It's quite a feature of our galaxy. And you can see it actually went into a bit of an X-ray hot mode here just in the past couple of days. That's not why I picked it. I just arbitrarily picked it because I like me some pulsars. So here's the 70-month average. This is the 70-month burst alert telescope average in hard X-ray. And look how differently it looks on the Chandra. The Chandra is very high resolution, and you can see all of the features there. A perfect view here of the Vela pulsar. You can see there's a jet oriented somewhat away from you located over here, and a jet oriented somewhat toward you over here. Chandra, some very, very high res imagery there in the X-ray spectrum. And the Vela pulsar is quite dark in things like infrared and even optical, as it is on the galactic plane, and there is a lot of stuff also on the galactic plane. So anyway, that's the Chandra imagery about the Vela pulsar. Continuing on to the astronomy picture of the day, apod.nasa.gov. You see that star right there? That's a star that some people think is dying, even though we've never seen a star die or get born. There's all kinds of crazy theories about how stars die and are born. So this nebular cloud being created here, this is NGC 7293, the Helix Nebula. And what you're looking at is hydrogen and oxygen. So this blue-green area in here, all these blue areas here, that's oxygen. The red colors are hydrogen. Two different chemical spectra there on the imagery at apod.nasa.gov. And guess what? That star right there didn't die in order to create this nebula. And yeah, I don't know what else to say other than the standard concordance model of stellar evolution is probably completely incorrect. Ask Pierre-Marie Robitaille. He would tend to agree. He likes things like observations and actual science done to more rationally explain what it is stars are made of. Anyway, apod.nasa.gov if you want to check that out yourself. Congratulations to Bill Shatner and the rest of his crew of 4 for making it to, quote, space, end quote. They experienced weightlessness and saw a black sky and the curvature of the planet. There's what it looked like in their phallic-shaped rocket. Yeah, Jeff Bezos blasted these people into space. I'll let the article scroll. This is on phys.org. There's the Chrome Dome himself congratulating Bill Shatner, who had a spectacular time. Space, a frontier. These are the voyages of the new industry of space tourism. Now, I proclaimed in 2012 I'd be going to space. As it becomes more and more likely, thanks to people like Jeff Bezos. And I don't have a lot to thank Jeff Bezos for, believe me. But this is a smart move. Space tourism, a significant industry, now taking off and becoming a reality, thanks to Blue Origin. Bill Shatner, we like him enough to name our Pleco James T. Kirk, after the character in Star Trek, yes. By the way, I like Picard a lot more than I like Kirk. I thought Kirk sucked. Kirk screwed up Starfleet, caused wars, and was generally a douche. Continuing on. We see no charging hazards for satellites at the moment. We cover it daily. As we like to anticipate things like communications breakdowns. Here's a one-year chart of the relativistic electrons from Solon.info to sort of put the electron flux in context. And here is the 3-day chart. Actually saw surprisingly low levels of electron flux. And we can expect a rapid uptick in the coming day or two. Noah would tend to agree. Check it out. The observations were surprisingly low here. And I would say the forecast should still be up here as we are expecting a high level of electron flux following that coronal mass ejection strike geomagnetic storm condition, coupled with a coronal hole wind stream. Here's a diagram of the Earth's Van Allen belts. The inner Van Allen belt, where the majority of the electrons are located, is at about 1 to 8,000 miles, depending on geomagnetic conditions. And here is a visualization of the total electron content up to a GPS satellite, which is located at about 12,000 miles of altitude. No major chaos happening. The electron belts are looking fairly well organized here. We did see some pretty high levels of electron flux there over the Central Pacific Ocean, but nothing to write home about. Here's another diagram of the atmosphere showing you where the F ionosphere layer is. Feel free to pause the video if you want to study things like electromagnetic radiation, penetration into the atmosphere, and so on. Here's the ionosphere. It's the ionogram showing vibrational frequency at about 300 kilometers of altitude. Vibrational frequency in megahertz. Nothing too crazy going on in the ionosphere at the moment. As far as I can tell, things looking pretty normal here. Here's the latest image from 9:30 Universal Time. Here's the anomalygram showing departure in megahertz from the 30-day median. And we do see some pretty significant low-frequency anomalies here, especially over the Pacific Ocean. Also some wild swings with a high-frequency to low-frequency anomaly shift. You can see all those dark red areas. Those are pretty major low-frequency anomalies. Here's the latest image. That's 9:30 Universal Time anomalygram. And here's the 9:30 Universal Time ionogram. We just recorded another great meteorology segment at twitch.tv/smAsho. Check it out. Udaipur, India's ground-based solar observatory is back online after being off for months, and we'll actually be using it today. Udaipur was undoubtedly shut down because of COVID-19. We are delighted to see that India is back. The Udaipur, India ground-based solar observatory, part of the National Sunspot Observatory, with the latest hydrogen alpha imagery. Yes, fantastic. We hope COVID-19 is finally closing down, as opposed to closing down the economy. Let's close down the COVID-19. What do you think? I think the concept is delightful. Here's an additional bonus feature. It's the latest intensity gram, and you can see these umbrae growing in front of this sunspot. Again, the likelihood of major flares, in my opinion, is a little higher than the automated flare monitor system might seem to think. And this is probably caused by the calibration of the SDO, the calibration maneuver that we saw. And you can see lots of complex fields here. Potential for major flares is certainly there. Let's close out the video with some composites. Here's 304 and 171 angstroms together. That's ionized helium and iron, if you're wondering. And we'll close out with 3 little animations here of Sunspot 2882, the star of the star. And there are some C-class flares included in that imagery there. Here's 131 angstroms. Oh, the SDO is just so good. It's spectacular. And we'll close out the video with 94 angstroms. So here's 94, one of the best wavelengths to view solar flares. Coronal mass ejection and solar flare warning remain in effect. Once again, congratulations on realizing our channel exists. Please support us via the links below the channel, and yes, I mean financially. And may that solar wind be at your back. Opinions expressed in this broadcast, not necessarily the opinions of Smash News Network. Least busted. Name it news.